Hello everyone, welcome back to Rockwell Automation series. Today I will continue with the topic device control. Now I will show you how to program for a two-way valve with add-on instruction. Last time for valve two-way, I already showed you how to program with the user-defined data type, the logic instruction and for instruction to scan on valves. Now I will show you a new method to program with add-on defined data type and add-on instruction. With this new method, we don't need to create array task and also no need to alias to a valve. In this video, I will show you step by step from creating a new add-on defined data type, add-on instruction, logic instruction of members in add-on instructions, and programming for controlling a two-way valve. Why we need to create a new add-on defined data type? The reason is the same with user-defined data type, but different. The add-on defined data type is used for add-on instruction. The reason is because in our process, there are many valves. If we don't create a new data type, we will take a lot of time to create a tag for valves. Each valve we need around 20 or 25 properties. So if we create a new data type, we will create tag for valve very fast. 10 valves, maybe around 10 minutes. Okay, we start. We come to the data type. Right click on add-on define folder and create a new data type. I name is AO valve two-way. Mean add-on valve two-way. Description I put a add-on define data type for two-way valve. Let the diagram revision select 10. Window, okay. For members or parameters, nothing new compared with the user-defined data type. I already said in the previous video about the programming for valve two-way with user-defined data type and for instruction. You can come to see in that video. Okay, create the members. Feedback close. Data type bool. This feedback from valve is close. Feedback open. Data type is bool. This feedback from valve is open. Open, close, red. Data type is bool. Set by the operator interface to close the valve when the valve is in the manual control. Open request. Data type bool. set by the operator interface to open the valve when the valve is the manual control. Pro command. Data type is bool. When set, the valve is requested to open. When clear, the valve requested to close. Secure interlock. Data type bool. Is used to override requests in case of safety issue. Process interlock. Data type also bool. It also interlock but related to a process condition to prevent the wrong operation. Upper auto request. Set by the operator interface to request auto control. Upper man request. Set by the operator interface to request manual control. Next, Pro Auto Request. Bool. Set by the user program to request auto control. Pro man request. Set by the user program to request the manual control. Automan. Set by the user. Set when in auto control. Clear when in manual control. Mod alarm. Set if the valve is in the manual control and a program command changed to a state, which is different from the state currently commanded by the operator. Override. Set by the secure interlock off to request the valve to enter override mode. Command status. Uses output. Data type bool. Set when the valve is being commanded to open and clear when the valve is being commanded to close. False alarm. Bool. Set if the valve were commanded to a new state and the fault timer has expired without the feedback indicating that the new state has actually been reached. Also set if after reaching a commanded state, the feedback suddenly indicates that the valve is no longer in the commanded state. The fault alarm is not latched and it resets as soon as the feedback indicates the right state. So the operator do not need to unlock the alarm. Output. The output of the instruction, which is commanding the valve. Sorry, I will change a little bit here. Automatically also output. Mod alarm also output. And phone alarm also output. Out revert. Pull. The default state of output is clear when the commanded to state closed and set when the commanded to state open. When out reverse is set, output is set when commanded to state closed and clear when commanded to state open. Phone timer. This is a timer. Okay, we will change to phone timer. It's a preset. This is the in. Phone timer reset. That is the timer will count from while receive the program command. If in the preset time, the valve on site do not move follow the command, the false alarm will be set and alarm on SCADA or SMI. That tag I name is the phone timer preset and data type is double in. Set phone timer preset to 0 to disable the phone timer. And next, ONS text. That text will use for one source, data type double integer. Okay, click on apply. Then OK. That's shown for new add-on define data type for two-way valve. After creating a new add-on define data type, add-on instruction will be the same name with the data type will be automatically generated here. We double click on the name and see the add-on instruction definition. We put a description here. Revision select here. Next, come to parameters tab here and see all the member we just create in the add-on define data type. In this list, tick on two columns, read and width here, request and visibility, require and visibility. Add the text you want to show on the add-on instruction interface. Here I select the feedback open, feedback closed, secure interlock, process interlock, and output. Then apply. For local text tab here, if we want to add any more text to program in the logic of AOI add-on instruction outside of members of data type we add here, then OK. Now we will program to define the logic between all members or properties of AO valve two-way. Firstly, we come to parameter and local text add-on instruction of AO valve two-way. You can see the text already here are the members or properties of add-on instruction. So we use them for logic programming. This tag will be a variable text. It means this tag used for command logic instruction of AO valve two-way. And when we want to use logic for specific valve, for example valve 0220, then the tag name will be replaced by valve 0220 and properties with the properties. For example, valve 0220 upper auto request. If we don't have this text, we need to copy the logic instruction for each valve. For example, we have 20 valves. Then we will copy the logic and replace the tag name in logic for 20 valves. We open the routine name logic in the AOI valve two-way and program exactly the same with the logic in the previous video about programming for valve two-way with user define data type and for instruction, but using add-on instruction text. Okay, we create logic for overlay. We add new run and insert a XIO. Secure interlock and lead to an OTE override. That's for override. Next is logic for auto or manual request. Add a new run. Insert the XIC. Upper auto request. Lead to an OTL. Automan. And a parallel an OTU. Upper man request. Add a new branch at beginning of a pop run. Insert a XIC. Pro auto request. Lead to an OTL automan. And parallel an OTU. Pro auto request. Add a new branch. Insert the XIC. Pro man request. Let's do an OTU automan and parallel OTU. Pro man request. Okay, that's all for auto and manual request. Next is open and close request. Create a new run. Insert the XIO override. Next XIO automan. Next XIC upper open request. Then lead to an OTE command status. After XIO automan, insert a new branch with XIO upper close request. And XIC command status. Then also lead to OTE command status. After XIO override, insert a new branch with XIC of 2 man. XIC pro command and XIC process in the log. Then also lead to OTE command status. That's for command status. Now program for operator open and close request. Create a new run. Insert the XIC open request. Lead to an OTU open request. At beginning, insert a brand with the XIC close request. Lead to an OTU close request. Sorry, I made text. Okay. This is for open and close request. Next, for output, create a new run with the XIC command status and XIO L reverse. Then lead to an OTE output. At beginning of a pop run, insert the XIO command status. And XIC L revert. Then also lead to an OTE output. Next, I will create the logic for phone alarm. We create a new run. I will use a NEQ not equal instruction. And compare the phone timer preset with 0. Next, I use XIC command status to determine the value requested to open. Next is one source. select one shot number 1. That's the condition to see the command from PLC to control the valve to open. And next we put the actual feedback from on-site valve with XIO and the text feedback open. Next is phone timer. I use timer on. For 5,000 first. Okay. That's the first reason. Next, I add a new branch after the NEQ instruction. Use XIC. Phone timer in. And XIO feedback close. Then come back to a bob run after one shot. That's the second reason. Next, we add a new branch after the NEQ instruction again. Use XIO command status to determine the valve requested to close. Next is one shot. I select one shot number 2. That is the condition to see the command from PLC to control the valve to close. And next we put the actual feedback from on-site valve with the XIO and attack the feedback close. And we connect this branch to the phone timer also. That is the third reason. Next, we add a new branch after the NEQ instruction again here. Use XIC. Phone timer in. And XIO feedback open. Then come back to a bob run after one shot. That's 4 reasons. Next is the condition for phone alarm bit. After NEQ instruction, we insert a new branch or create a new run and XIC phone timer DN. Little and OTE phone alarm. Next, we add a new branch after the NEQ instruction again. Here. Use XIO feedback close. and XIO feedback open. And XIO phone timer in. Then lead to OT phone alarm. That's fifth reason. Next for mode alarm. When we have the mode alarm, it's when the valve is in the manual control and a program command change to a state which is different from the state currently commanded by the operator. This alarm is intended as a reminder that the valve were left in manual control. Create a new run. Insert XIO Automand. XIO override. XIO Pro command. One shot number 3. XIC command status. XIC process interlock. Then lead to an OTL mode alarm. After XIO override, insert new branch. Next is XIC Pro command. One shot number 4. XIO command status. And come back to above run, but before XICE process interlock. After XIO override, insert a new branch. Next is XIC command status. One shot number 5. XIC Pro command. And lead to an OTU mode alarm. After XIO override, insert a new branch here. Next is XIO command status. One shot number 6. XIO Pro command. And come back to above run and also lead to OTU mode alarm. Parallel with above run, insert a new branch. Next is XIC Pro command. One shot number 7. XIC command status. And also link to OTU mod alarm. Parallel with the mod run, insert a new branch. Next is XIO pro command. One shot number 8. XIO command status. And also link to OTU mod alarm. Create a new run. Insert the XIC auto command. And XIO command status. Then link to an OTU mod alarm. Insert new branch. Insert the XIO override. Insert one shot number 9. Then link to OTU mod alarm. Okay, that's all for logic of mod alarm. Now I will create a tag for a valve. Use this data type. Create a tag name in a controller tag. Tag name V0220 with a data type AO valve two-way. Now we create the program for AO valve two-way. Come to the basic control. Create a new program. Name AOI. This means add-on. Instruction. Create a new routine. Name AO valve two-way. With a ladder diagram and non-assignment. Then open it. On a new run, we insert AO valve two-way. Instruction. Okay. For name, we put V0220. For feedback open, we select the text from digital input modules and the feedback close. This is close 0220. We created new local tag alias for the input digital. Here data we want to create. For feedback open, select the tag from digital input module also and the feedback open 0220. Alias IP16 input data number 2. For secure interlock and process interlock, we need to program outside and move to here the text direct set or reset the secure interlock and process interlock. We create a routine for valve interlock. Name AO valve interlock with ladder diagram and non-assignment. Firstly, about the secure interlock, I put a mandatory condition EXIC emergency stop on lead to an OTE of a new text V0220 underscore secure interlock with a data type bool. If we have any condition here, we will put here. Second, about the process interlock, I put one condition here bit1102 underscore pv greater than 5 bar. GRT PIT 5 bar. Then lead to OTE of a new text V0220 underscore process interlock with a data type bool, new bool create. Okay, now we use two text V0220 underscore secure interlock and V0220 underscore process interlock for secure interlock and process interlock in the AO valve two-way of valve 0220. We come back to here. We put next for output. We input into output with a text alias to a digital output, and that output will connect to the valve on site. We put it the output 0220 and create that text alias to DO output, digital output here. Select the channel data channel 0, create. Now we create the main routine in the program and call this routine to run. Right click on AOI program and insert a new routine. We name it the main routine and assignment. We select main. Open main routine and insert a run to use GSR. Jump to subroutine. To call the subroutine, we jump to two routine AO file two-way and AO valve interlock. Okay, now we come to the program and control this valve. In this application, this valve V0220 will open if the level of the tank is L1201 underscore PV E achieve 80% and closed when that level is under 20%. We create a routine with name the V0220. Okay, you can program for it in another program. Open it. Okay, now I will create a basic program to control this valve. Normally, to control the level of the tank via a valve, we will use the BAD, but in this video, I will focus on the valve only. So for the BAD, I will create another video for it. We add a new run inside a GRT instruction. GRT. For the SUC, I will put L1201 PV. SUC P will put 80. This GRT lead to OTL V0220 Pro command. We add a new run inside LES. SUC A L1201 PV. SUC B is 20. This LES lead to OTU V0220 Pro command. Okay. Okay, that's all for the valve two-way programming with add-on define data type and add-on instruction. Okay, you can do it by yourself. See you in the next video.